Select the resonance structure formed by the curved arrows shown below. So what we need to do to solve this problem is to follow the arrows. So your arrows, curved arrows, always indicate the flow of electrons. And so what we see here is we started with a lone pair on this carbon and we moved it in between the carbon and the nitrogen. So that indicates that we are forming an additional bond between those two atoms. This nitrogen had a triple bond to another nitrogen, but we're moving one of those pi bonds onto the N nitrogen. So we will be left with just a double bond. That nitrogen had a lone pair of electrons, and now it has an additional lone pair of electrons. So we moved electrons away from this negatively charged carbon atom, and it ends up neutral. And you can confirm that by calculating the formal charge. This is pushing electrons in towards the center nitrogen, but then we're also taking electrons away, so the overall charge does not change on that center nitrogen. And if we look at the N nitrogen, we are pushing electrons onto it. And so by following the fact that we're putting electrons on there, and also we could calculate the formal charge, we would see that we would have a negative charge on that N nitrogen. Another thing we want to check with these structures is to make sure that the overall charge is conserved. We should not have accidentally gained or lost any electrons. So if we look at what we started with, we had a negative charge on carbon and a positive charge on nitrogen, so that it was overall neutral. In this resonance structure, we have a positive charge on nitrogen and a negative charge on the other nitrogen, so it is still overall neutral. And this structure matches option B.